When you first look at the periodic table of elements, it can be quite overwhelming, especially if you don't know what you're looking for. With a few short, easy tips, you'll be able to navigate through the periodic table of elements in no time. The periodic table of elements is arranged in special ways so you can navigate through it quickly. Some of the three main arrangements on the periodic table would be periods, groups, and families. There are 7 total periods on the periodic table. They are in rows that are horizontal, so they go from the left to the right on the periodic table. They increase in atomic number as you move across that row, and there's a total of 7 of them. Another category of the periodic table would be a group. A group is going to have a column, and that column is going to be from the top down to the bottom. There's a total of 18 columns on the periodic table. Families is another way to categorize on the periodic table. They have similar properties that make them in this same family. And examples of those families would be the alkali metals, the alkaline earth metals, transition metals, the rare earth metals, and halogens, and the noble gases, to name a few of the actual families that are more common on the periodic table. If you look at the periodic table of elements, you're going to find 2 very special elements up on top. One is hydrogen and one is helium. Hydrogen is a special element because it is the lightest element on the periodic table. It has 1 proton, 1 electron, and it doesn't have any neutrons. It also has the lightest atomic mass and the lowest atomic number. One special thing about hydrogen is that it's a non-metal, but it's located on the metal side of the periodic table. Helium is special because it is the second most lightest element on the periodic table. Helium is the start of the family of the noble gases. The noble gases, you'll find out as we start studying bonds, have a complete outer shell. Hydrogen is the only atom on the periodic table that has 2 valence electrons in its outer shell. No other element has that special characteristic. When you look at the periodic table of elements, it's grouped into different categories or types. The elements are going to either be a metal, non-metal, or a metalloid. To talk about each category, we'll start with metals first. Metals are the majority of the elements that are on the periodic table. They are solid, and they're typically shiny. They're good conductors of electricity and heat. So if you look at your heating or cooling ducts in your household, they're going to be made of a metal because they can conduct that airflow to a different location and keep that correct temperature for you. They're also malleable. That means that you can pound them into thin sheets, just like aluminum foil. Or ductile, which means that you can draw them into thin wires, which makes those metals perfect to use in electronics to pull that electricity current through. You also have a category type of nonmetals. There's 17 nonmetals on the periodic table. This would include hydrogen. Remember, it's over on the metal side, but it is considered a nonmetal. And typically nonmetals are liquids or they're gases, and they're very dull and they're brittle as well. Your last category type would be metalloids. They're going to be on either side of the zigzag line or the stair step that is on the far right side of the periodic table that separates your metals from your nonmetals on your periodic table. They are also called semi-metals because sometimes they can take the properties of a metal or the properties of a non-metal. It just depends on what they have to do when they bond. They are typically dull or they could be shiny. Just depends on their characteristics. And sometimes or often enough they can be malleable and ductile as well. Elements on the periodic table are grouped together because they have similar properties or characteristics that make them very similar to one another. So starting over on the left-hand side, we have our very first group. Remember that hydrogen is not included in this group, but it does fit there because of it being the lightest element on the periodic table. So our first group that we're going to talk about is the alkali metals. The alkali metals are the most reactive family or group on the periodic table. You're going to see that they do react and are common in a lot of compounds. The second group on the periodic table that we're going to talk about is the alkaline earth metals. They're the second most reactive group on the periodic table, and they are common with bonds as well. Then you move to the transition metals. So the transition metals are in the center of the periodic table. They're groups 3 through 12. And you could say they're in transition on the periodic table because they are reactive. They're less reactive than groups 1 and 2, but they can react and make bonds with other elements on the periodic table. Your rare earth elements are at the very bottom. They've been pulled out of the periodic table so it can condense its size, but they are part of period 6 and 7, but they've been pulled out so you can see the spacing a lot better on there. But they are considered the rare earth metals. And then over on the far right side of the periodic table, we have group 17, which is known as the halogen group. And this is another group that you're going to see is going to be reactive with the opposite side of the periodic table when we talk about ionic bonds. And then the noble gases, they're the royalty of the periodic table. They're group 18. They don't need to interact with the periodic table because they're stable, and we'll talk more about their octet when we get into bonding as well.
So by looking at each square of the periodic table, you can actually learn a lot of information. The very first thing you normally see is a letter or 2 letters, or sometimes 3 letters, in the middle of the square, and that is the symbol. And we use this symbol when we're doing balancing equations or bonding. Instead of writing out the word carbon every time, we can just designate it with a C. Sometimes it's the first letter of the word, but that's not always the case. So sometimes it is like the Latin word, and it'll be the first letter of the Latin word, like gold. So we don't use a G to designate gold, we use a U. The next thing you'll see is the atomic number. It's normally in the top left or somewhere near the top, and it goes in order through the periodic table. So hydrogen is number 1, and it goes 2 for helium, and it goes all the way down. So the atomic number is very useful. It's used to identify the element, obviously, but it also gives us the number of protons, and it gives us the number of electrons. So the way to remember that, we use APE, A-P-E, so the atomic number, the A, is the same as P for protons and then E for electrons. If you look at the bottom of the box, you'll normally see a number that's a decimal. Sometimes it is rounded, sometimes it's not. That is the atomic mass. And like the atomic number that gets larger as you go through the periodic table, so does the atomic mass. And the atomic mass is helpful because it can also give us the number of neutrons, and we need the number of neutrons often. So to remember that, we use the phrase man. M as you take the atomic mass for M, and you subtract the atomic number A, and you get the number of neutrons, which is your N. So if you remember ape man, you can fill out everything you need about the periodic table or each element. So you have the symbol, which is different, it's just the letter in there. You have the number, the atomic number, the atomic mass, both of those are in the square, but you can also use ape man to figure out the number of protons and electrons and the number of neutrons. And you're going to practice that in this next clip with Mrs. Willie, but you're also going to practice that for on the worksheet, the periodic table worksheet. So it's important that you know how to do that. Remember ape man.
Let's do an example together using our new information about ape man to fill out the information on a periodic table example. So if we're using phosphorus as an element that we want to obtain information from, we're going to locate that on the periodic table by either looking for its atomic number or by its chemical symbol. So if you look on the periodic table for phosphorus, you will find that its chemical symbol is a P, an uppercase P. It's only one single letter. You will also find that its atomic number is 15. Knowing the atomic number, you now have enough information to fill in two other parts of that APE memory device. So your atomic number is 15, your number of protons is 15, is the same as the number of electrons, which is 15. So looking at your example, you now have atomic number filled in at 15, your number of protons is 15, and your number of electrons is 15. The last two things you have to fill out would be your atomic mass, which is at the bottom of the square, which is 30.947. And you're going to use that information along with your atomic number to get your number of neutrons. So this is where that MAN memory device actually comes into play. So you're going to take your atomic mass, which you're going to round it in this case up to 31. You're going to subtract the atomic number from that, which is 15, and it's going to equal your number of neutrons that you have, which is a total of 16. When you subtract 15 from 31, you get 16. So that is how you use the periodic table square to obtain information about each individual element and its subatomic particles.